have done this in class. Got these numbers in ordered pair, that's 5 and 41, and 20 and 146. You graph them. You see the little blue lines in here, these are your graphs for those coordinates. Now in some of my class I use 10, the interval 10 over here, right here. In my other class, as you can see, we use 20. It really doesn't matter. Just make sure it fits all the number. Is this graph a function? It's a function because the vertical line only cross the graph once. As you can see, if you draw a vertical line on each dot, there's only one dot per vertical line, therefore it's a function. Okay, now, a taxi service charge a $5 flat fee plus a $3 per mile travel. Now, per means times. $5 flat fee, so it costs you $5 flat, nothing else, plus $3 for each mile, per mile. So instead of writing out the word mile there, because we don't know how many miles, it says write an equation for the total cost for any taxi ride. So for any taxi ride, we need to know the mileage in order to find the total cost. Okay? So, here, first you went to 9 miles. 5 plus 3 times the 9 miles. 27 plus 5 is $32. Now, then you have another customer that went for 12 miles. So this is 9 and 32. You can put 9, you get out 32. 5 miles, $5 to get in the car. 3 miles automatic charge. Okay, and you went 5 miles for an automatic charge, 3 miles per mile. $3 per mile. Multiply that, you get $36 for the mileage and $5 for getting in the car, for a total of $41 for 12 miles. Okay, you choose your own. I'll choose 5 here. Let's say 5 miles. 5 plus 3 miles per hour. Let's say it is, okay, the ordered pair here is 12 and 41. Say the mileage here is 2. Oh no, mileage is 5. I'm sorry, goodness gracious. Mileage is 5 here. That's 15 plus 5 is $20 for 5 miles. Now, here they're saying you paid the taxi $95. The taxi driver wanted $95. How many miles would they have gone? First, minus the flat fee. That's the fee that just lets the taxi driver let you in the car. That gives you $90 left. Okay, $90, well, there's $3 for each mile. So in order to determine how many miles you went, you need to divide 90 by 3 and get 30 miles. That gets you 30 miles. So your ordered pair here is 30 and your answer of 95. Okay, then you graph that. Oh, 9 and 32. Oh, you need to do an interval table because there's no number here. 9 and 32, the lowest interval. This is the lowest number. Is 5. The highest number of mileage was 30. Right there. Miles with miles. Okay? Now, total cost. Total cost of everything. Okay, the lowest total cost was $20. The highest total cost was $95. Now the interval, right here I had you guys write the word interval. It's not there anymore. But the interval I would count by to fit in here, 2, 4, 6, 8, 10. I think 30 fits in there, so I'm going to count by 2. The total cost, definitely 5, 10, 15. Yeah, I think by 5, 35, 45, 55, 65, 75. No, I think 5 would work. 5 would fit in here. So I count by 2s. 2's for the number of mileage. Okay, so first, oh no, why is it not letting me erase? This is the mileage. We're going to count the mileage by 2. Just to make sure, I need to get to 30. So here's 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, oh no, 26, 28, 30, yeah, it fits 30, 32, 34, 36, 38. Okay, it fits all the numbers to 30 because we want to fit 30. Up going, making 95, let's see if they'll make it. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Yes, it fits the 95. Okay, so our first order of pair is 9 and 32. Well, 9 is between 8 and 10. Smack in the middle, right? Here. And go up to 32. 32, about somewhere there. $12 and 41. There. And 5 and 20. And 30 and 95. 30, go up all the way to 95. Right there. That's your graph. It's linear. It's a discrete. This is a discrete linear. Okay. So what that means is we can connect it. Alrighty. Is the graph a function? Use the vertical line. Okay. This is a function because the vertical line only crosses that graph once. It's a function because the vertical line only passes through the graph, through the linear graph,